welcome you, our global audience, to another session of the 2025 edition of Targeting Healthy Longevity, a conference that's been going since 2017. We've got a fascinating program for you today, and we'll be discussing some of the most promising approaches for increasing health span. But I first want to welcome Connexum CSO Dr. Michael Zimmel, who is preeminent in translating promising data into products. Michael is standing in for our usual co-host, Thomas Sir, who is off in Hong Kong, presenting at a neuroscience conference. And actually, Thomas is still with us, but we thought we would make sure that we had somebody a little closer to co-moderate this session. So Thomas, great to have you joining on very late from Hong Kong. Michael, over to you for a few housekeeping
Oh,
announcements.
thanks, Ann. So first major housekeeping reminder is to please enter your questions into the Zoom webinar Q&A as our panelists are presenting, and then we will utilize them during the roundtable. A link to the recording will be circulated to everyone here, all registrants, and actually made publicly available within the next business day or two. Also, we have the chat function enabled for audience interaction. It'd be great if those of you who are willing would just say hi in the chat, state your affiliation, and perhaps where you're logged in from, just to get the chat moving. And finally, thanks for those of you who have submitted questions. We've received several excellent questions. To those, we will add those that we receive in real time using the Q&A function. So again, please do use that function. And the panelists will try to get to as many as there's time for. At this point, I'm going to throw the mic back to our moderator, Alexander or Zan Fleming, the founder and executive chairman of Connexum. Connexum is a regulatory, clinical, and product development strategic advisory firm. Zan also serves as president and founder of the not-for-profit Catalyst Institute, whose mission is to catalyze science into solutions for preventing chronic diseases and extending healthy longevity for all. Back to you, Zan.
Well, thank you very much, Michael. I want to start by explaining the reference to the Thrive Act. And we won't get into details about the Thrive Act today, but you can find them on the Catalyst website. For sure, this act is intended to catalyze the development and availability of products that increase health span. But perhaps the most audacious feature of the act is that it applies to all categories of FDA regulated products, drugs and biologics, of course, but also medical devices and even dietary supplements. And that is because all solutions for targeting healthy longevity should be encouraged and supported by strong scientific evidence. In other words, we are looking for products like, or for labels like this, for a drug, for a biologic product, for a supplement, and even a medical device. So that brings us to who I will call the Thrive Four. Each of our distinguished panelists represents one of these categories. And note that the companies that they lead span the spectrum from being preclinical to being marketed, though without health span claims. So note a time that binds. Each of these companies are targeting deep roots of aging biology. In various ways, they target the mitochondria. And so I think it's very interesting that we have these major differences, but this commonality is very intriguing. So without further ado, I'm going to introduce our first panelist, who is being summoned to NIH for a important meeting, and we're therefore going to put him first. Dr. Josh Hare, who is a preeminent radiologist and medical scientist, who is founder and executive chairman of Longeveron, uh, company based in Miami. So, right, Josh, go right ahead, and you can now share your slides. You'll see them,
Yeah. Um,
and you can go to presentation mode, and there we go.
uh, Terrific. Can everybody see the slides and hear
We
me?
do.
Yeah.
Wonderful. Well, it's such a pleasure to be here with you all. Zan, thank you so much for including me on this very exciting panel. Um, what I'd like to talk about today is the use of cell-based therapy for health span extension. And I'll be addressing specifically two conditions, one known as aging frailty and the other Alzheimer's disease. These are clear-cut diseases of aging and play a major impact on limiting health span. The work I'm going to talk about um, uh, has been conducted at the company that I co-founded called Longeveron. You see my disclosure there below. And these assets are actually at phase 2, getting ready for pivotal trials. So we're very excited about the possibility of bringing these products to market in the next 5 years. Here's a mandatory forward-looking statement because Longeveron is publicly traded. And let me just jump right into it. So laromestrocel, also known as Lomecel B, is the product manufactured by Longeveron. The technology for this product was licensed from the University of Miami. It's a proprietary formulation of bone marrow-derived mesenchymal stem cells. This product is designed to address one of the key hallmarks of aging, which is the loss of stem cell reservoirs and potency with aging. Laromestrocel is also capable of modulating inflammaging and mitochondrial deficiency, two other key hallmarks of aging. Collectively, laromestrocel can address pathobiology characterized by fibrosis, inflammation, vascular dysfunction, and loss of healthy cells in the aging scenario lost due to senescence. This is how laromestrocel is developed. I won't go into detail here in the interest of time, but it is isolated from young, healthy donors and culture expanded in a specialized laboratory that is housed in Miami, Florida, called the GMP laboratory, and laromestrocel can be administered to patients intravenously with a 40-minute IV infusion that has been shown in hundreds of patients to be very safe. Now, laromestrocel, how does laromestrocel work? Well, although it's called a stem cell, it doesn't actually engraft in the body and form new tissue. Rather, laromestrocel is a very powerful factory that's capable of producing growth factors and cytokines that can immunomodulate. It can actually form cell-cell interactions with host tissues. Perhaps one of the most important and increasingly recognized activities is the release of exosomes, which are microvesicles containing a rich abundance of microRNAs and other proteins that can traffic throughout the bloodstream and reach distant targets, thereby explaining why laromestrocel can be infused intravenously and can reach distant targets such as the brain. One of the very exciting features of this product is that it can also form what are known as nanotube bridges that are large enough to allow the transfer of mitochondria from the Lomecel B to aged recipient somatic cells, meaning that the use of this product can also lead into a rejuvenation of mitochondrial dysfunction in a host. Collectively, these mechanisms of action, as I mentioned before, have a provascular, proendothelial effect, an anti-inflammatory effect, an antifibrotic effect, and can stimulate intrinsic regenerative repair. These four mechanisms have been shown widely in multiple clinical trials and preclinical models throughout the world, again, in multiple laboratories. So we became very interested about 10 years ago in examining whether infusions of these cells could improve the condition known as aging frailty. To me, aging frailty is the prototypic clinical scenario that describes what poor health span is. I think we all know that poor health span is the divergence between lifespan and quality of life, such that the last in the United States, decade plus of life is characterized by poor health and poor physical capacity. This is clinically described as frailty, whereby individuals get a disproportionate loss of physical functioning and other parameters. And this can be nicely measured with the 6-minute walk test. A normal 6-minute walk test is about 500 meters in healthy adults. And we enrolled subjects in the study who had frailty and had an average walk distance of about 300 meters, so a substantially impaired um, 6-minute walk test. We infused in these patients, here as you can see, 5 different doses, the lowest being placebo, so an inert material, and then an increasing dose of laromestrocel. And what you see is a time-dependent increase in 6-minute walk distance that's time-dependent and also dose-dependent. This is very important because it speaks to the biological activity of the compound, the cell compound. And you could see that the clinically meaningfulness can be assessed by looking at the day 270, the 9-month change in 6-minute walk test between 200 million cells and placebo is 63.4 meters. It's highly statistically significant. And a 63.4-meter increase in your ability to walk over 9 months is very medically meaningful for an older individual with a poor health span. We went further in the study to show that the dose response was statistically significant in the left panel, and moreover, the increase in 6-minute walk test correlated with a patient self-reported outcome called the PROMIS-PF, so that as patients could walk more, they also perceived feeling better. As a result of that study, which was very exciting to us, we decided to tackle another disease of aging, which is Alzheimer's disease. Alzheimer's disease is a devastating neurocognitive disorder affecting 6.2 million Americans, expected to double by 2060. And you can see one of the hallmarks of Alzheimer's disease is substantial atrophy of the brain. You see in the right, the healthy brain slice compared with the marked atrophy that an Alzheimer's disease subject confronts. And one of the key areas that is markedly atrophied is a structure at the base of the brain known as the hippocampus, which is the structure that's responsible for new memory formation and for emotional regulation. In this study, which was just published in Nature Medicine in April of this year, we were very excited to see a very good safety profile, as well as a statistically significant improvement in the pre-specified secondary endpoint, which was a CADS score, which is a composite of these 4 measures you see here on the right, the CDR-SB, the ADC-ADL, the ADAS-Cog, and the left hippocampal volume. Again, similar to what you see in the aging frailty, you see a time-dependent effect. There's a decline in the placebo group, shown here in the black line, and an offset in the subjects that received the laromestrocel. If we drill down deeper and looked at specific measures of cognitive function, you see that it's a very nice effect. In fact, it's high. The statistical significance is greater in the individual metric of cognitive function. This is the MoCA total score. It's a measure of cognitive function. You see in the placebo group over the 39 weeks, a tendency to be level or decline. And you see the very nice offset by all 3 doses of the laromestrocel. I should also mention that some of the groups here got multiple doses versus a single dose. So there's a dose dependence as well as a cumulative effect of giving multiple doses. We also see a similar tendency in the change in the mini mental score. Now, what about the biological underpinning of this? Well, I already mentioned atrophy and hippocampal atrophy. Fortunately, we can measure this with great precision in humans using MRI. Here you see an MRI from one of the subjects in one of our studies. And you could delineate the hippocampus and all of its subregions, actually, and you can quantify their size. So we built this into the study. Remember, I'd mentioned that one of the things that laromestrocel does is renew tissue, rejuvenates tissue. And we were intrigued to ask the question, is the clinical effect derived from an association with a preservation of the hippocampus or other structures of the brain? And lo and behold, it is. So we did what's called volumetric MRI, where we overlay the MRIs over time from an individual subject, as shown here in panel A. This is published, by the way, if you want to get greater detail. And what you could see is that there's rather substantial atrophy in the placebo subjects, as shown in the right panel. This is how it's measured in the left panel. And you can see the offset created by the administration of the laromestrocel, and there is a dose response here. The more we gave, the greater the effect to reduce the amount of atrophy. And you can see here at the highest dose at 16 weeks, it's actually prevented any decline in whole brain volume compared to the placebo group. So that early time point is very important and speaks to perhaps the continued needing to dose. Now, what's the mechanism of action? Well, I gave you the general mechanisms of action, but we're trying to delve deeper and find a specific molecular mechanism of action. And we believe we've uncovered a specific signaling pathway known as the Tie2 pathway. Tie2 is, as you could see in this study, going back to the aging frailty, Tie2 tends to increase over time in placebo patients. This occurred both with aging frailty and with Alzheimer's disease. And Lomecel B prevents or actually reverses the increased appearance of Tie2 in the circulation. Why is this important? Soluble Tie2 is the receptor that sits on endothelium that has a downstream regulation of both inflammatory responses and angiogenesis. When that receptor is cleaved, it released into the circulation, and you can measure that cleavage by showing the increased appearance of Tie2 in the circulation, as we see in our placebo patients. We believe that Lomecel B is reducing the cleavage of Tie2, thereby showing a decline in the soluble proportion, suggesting a preservation of the Tie2 receptor on cells and tissues, and enabling healthy downstream signaling that exerts an anti-inflammatory response and a pro-vascular response. I'm thrilled to be here with you today. I look forward to the discussion. I must end by thanking my team at the University of Miami, Longeveron, and all of the numerous awards we've received from the federal government that has supported this work over time. Grants to both the University of Miami as well as Longeveron that has funded these studies. Again, thank you, and I look forward to the rest of the program.
Well, Josh, thank you. These are just absolutely spectacular results, and they should be wider known. Very promising. And as you say, you're targeting now to the hallmark of aging. You've
With that,
already
I'm going
got.
to jump off for 10 minutes, and I'll be back to join you in just a few minutes.
All right. Well, do
Thank
come
you so
back as
much.
soon as you can. You bet. All right. Well, let us now go on to Dr. James Carroll, a scientist himself and no stranger to this conference. He is CEO of Thor Photo Medicine, and he's going to provide an overview of how photobiomodulation could increase healthy longevity. So, James, over to you.
Right. See my slide. Can you see my slides? Oh, people are nodding. Right. I was expecting a verbal. Anyway. first of all, I should say that thank you for introducing me as Dr. James Carroll. I haven't even started my PhD yet, though I am actually writing a letter now for trying to start that. So I will introduce my credentials. Also, at the top of the not the presentation, but your introduction about 15 minutes ago, Zan, there was a future-looking thing that somebody wrote. It wasn't written by me, and it included an ambition to maybe prevent cancer or something, which is not something. None of that was written by me, and they're not formally any ambitions of ours. But let me introduce what we are doing and where we think we're going. I'm going to do a disclaimer. So in the United States, our products are permitted to claim temporary increase in local blood circulation, temporary relief of minor muscle pain, joint pain, aches and stiffness, relaxation of muscles and muscle spasms, minor pain and stiffness associated with arthritis. Any other condition mentioned in this presentation is not cleared or approved by FDA for Thor products in the United States. FDA is not approved or cleared photobiomodulation as such, at least not by that name, in the United States. And the other countries where we've got approvals for treatment of tendinopathies, chronic joint pain, back pain, and oral mucositis. What is photobiomodulation? It's something, and you all look old enough to have seen this show, TV, Star Trek, and then somebody gets injured, get taken to the doctor, who gets out a laser, aims the laser at the injury, and the injury heals instantly. So we make those. Any questions? Okay, so it's not as fast as on TV. We get the idea. We shine light on people, and they heal more quickly. By the way, instant healing is not an FDA-cleared indication for use for us. So in the field, not just Thor, but there's over 1,700 randomized placebo-controlled clinical trials published in this, over thousands of laboratory studies, over 11,000 academic papers in total published. 174 papers have got my name on it and or Thor's products in it. We calculate that our products have delivered more than 37 million treatments to date, yet most doctors have never heard of it. It has a wide range of applications. How can one medicine treat so many different conditions? You should never believe anything that appears to do everything. It doesn't do everything. It does one thing. It does it very well. And that is it's very good at regulating the production of reactive oxygen species, which this audience will know will come mostly from mitochondria. So when we're sick, stressed, injured, or just old, our cells tend to be low in energy, ATP, tend to be high in the production of reactive oxygen species. And you all know that too many reactive oxygen species for too long overwhelms the body's natural antioxidant mechanisms, leading to oxidative stress, leading to the inflammatory cytokines, leading to inflammation and cell death. And the like, when we put light into patients, it's absorbed in mitochondria, and it changes the balance from production of more energy, ATP, and fewer reactive oxygen species, reducing oxidative stress and having a lot of interesting effects on NRF2 pathways and regulatory T cells and production of stem cells and growth factors. But we haven't got time to do with that, and I haven't got time to take you through the full map, but it leads to faster repair of tissue, less edema, less inflammation, and less pain. There's a dose response. If we don't put enough light in, we don't have any effect. If we put too much light in, we can have accidentally two inhibitory effects. And it's not as simple as just too much or too little. That could be either too much intensity or it could be too much time. But it's more to do with a balance of irradiance and time. So irradiance is the physics word for intensity of light. So very low intensity, for as long as you like, could produce no effect at all if it's too low. But if too much intensity, for a short period, you might get a bump in some positive effects, but you can actually end up slowing things down by accident if you're not careful. The holy grail is to find this curve here. This is where my area of expertise is in how much light is enough and how much is too much to get the optimal effects. Just to give you some medical applications before we talk about health and longevity. Oral mucositis, a horrible side effect of high-dose chemotherapy or radiotherapy. In severe cases, people can't eat, drink, or swallow, not even swallow their own spit. And that's, you can't imagine it. We've been in multiple studies. Here's one at the largest treatment center in the UK, the Christie, treating base of tongue cancer or tonsil cancer patients. Preventatively, we apply this before people have any symptoms. And here it's showing a 63% reduction in the use of morphine and an 88.7% of patients who need to be hospitalized because they can't eat, drink, or swallow because the side effects are so severe. That's about 30% of head and neck cancer patients have to be hospitalized for those reasons. We reduced that by 88.7%. This was a tiny NHS study. This has been repeated in other hospitals now in much larger studies, but only the Christie did the hospitalization measurements. But nothing else does that. And that's the point I want to make over the next few slides. Fibromyalgia, nothing works for fibromyalgia. We did a randomized trial on 42 patients with placebo control. A patient just lie in this thing for 20 minutes, 3 times a week, and this study for 4 weeks. We have this reduction in pain. So these are baseline figures coming into the study. 2 weeks of treatment, 4 weeks of treatment, 2-week follow-up with no treatment, 6-month follow-up, and you see the benefits are maintained. That's for pain. Kinesiophobia is fear of movement, and you can see that continues to come down over even in the follow-up period. Self-efficacy is going up. Quality of life is going up. And leisure activity is going up. These are all very positive effects. For people, about 30% of these patients are unemployed or cannot maintain a job. So severe is fibromyalgia, and I'm hoping you've all heard of it. And nothing else does that. Age-related macular degeneration is another company I co-founded, Lumithera. It's the leading cause of blindness in the developed world. There's 2 kinds. There's the wet form and the dry form, which is 90% of patients. Dry form is considered untreatable. The wet form, you can have injections in your eye to slow progression. If you don't have AMD, you can see 4 kids in my kitchen. If you develop AMD, you begin to lose central vision. You have distortions in your vision. You begin to lose contrast sensitivity. You develop these blind spots called geographic atrophy, which gradually get worse until you can't read, you can't drive, you lose your driving license, and you can't enjoy TV. So it reduces or inhibits greatly independent living. So it's a great cost to social services. We developed a device like this for ophthalmologists, and we did a 10-center style across the United States. Here, this is a placebo group. I was surprised by how big the placebo response was. Well, I say it was placebo. Actually, it was just a very low dose, and maybe a very low dose contributed to this effect. But the active treatment group here, this is over 24 weeks, 3 times a week for 3 weeks, 3 bursts of that in a year, another 3 bursts in the 2nd year here, and it's obvious what's going on here. We have a mean score of 5.9 letters. If you're familiar with the Snellen chart here, there's 5 letters per line. To have 5.9 letters as an average is basically a whole line, more than 1 whole line further down the chart for a disease that only ever gets worse. So we had 5.4 letter gain at 12 months, at 2 years, 5.9. 58.2% of patients actually had an 8.5 letter gain, 18% had a 13 letter gain, and 5% of patients actually did 16. That's 3 lines of improvement for a disease that only ever gets worse, and nothing else comes close to doing this. This is all done with photobiomodulation. It's got its marketing authorization in November last year. And the company was purchased for a very large sum of money a few weeks ago from Alcon, which is the world's largest ophthalmology sort of drug and device distribution company. Anyway, back to this topic today, which is about health and longevity. Photobiomodulation has been clinically proven to enhance exercise performance. It's like one of the strongest proven beneficial effects for improving health span is exercise, different kinds of exercise, like zone 2 exercise and lifting weights. But it's in both cases, PBM has been shown to help. I'm going to show you some data. It improves sleep quality. I'm going to show you data on that. It reduces nocturnal hypertension. Not showing you that today. Reduce oxidative damage is one of the fundamentals of photobiomodulation. Improves heart rate variability. You're about to see that. Reduces resting heart rate and improves the VO2 max. Again, associated with all of these are associated with a reduced risk of all-cause mortality. So in one study, all of these were covered: sleep, resting heart rate, and heart rate variability. Recovery is critical for professional athletes, military forces, who want to train hard. In a study on 12 elite female soccer players using the Aura Ring, I know or has its imperfections in terms of you wouldn't use it in a hospital for judging people's heart rate or heart rate variability, but it is reliable for individual uses. So you can see the changes. The changes are reliable, even if it's not a hospital level metric. These players are only going to use the Novathor a maximum of twice a month over a whole season. Most of the time, they're just collecting baseline data. How do these patients wake up? What are their heart rate and their heart rate variability? What is their sleep like? A lot of baseline data. Then they use the Novathor occasionally, like twice a month. So they went and they have like a 2-week washout period. And you can see what happens when they wake up the morning after the night before they had a Novathor treatment. Novathor is a whole body treatment system. I forgot to introduce that. Yeah. So, and this is what we see. So this, the y-axis here showing total sleep time, and the blue line's the baseline data. This is the treatment, the morning after treatments. And what you see is a reduction in sleep. Now, most people think, well, that's a bad thing. Surely we should be sleeping more. However, there is this, the bottom line here is the heart rate, resting heart rate, and you can see the resting heart rate has dropped. This is a sign of recovery in professional, hardworking athletes. This is a very interesting sign of what the Army call readiness. Over here, heart rate variability, again, there's sleep. This is the night after using the Novathor, sorry, the morning after the night before when they had Novathor treatment. So one treatment shifts heart rate variability to the right as well. So it is a very interesting one shot only, 2 weeks washout before you try it again, and then do it again consistently, showing that you sleep better and have a better resting heart rate and VO2 max after PBM. And this is a study on using photobiomodulation. They're just on the front and the backs of the legs. Here, they're doing lots of individual points. This is before we had the Novathor. And the changes in VO2 max, another good indicator for all-cause mortality here, is increasing here. And speaking to elite forces, as we do, because the Army, Navy, and Air Force are big customers of ours, we get this significant improvement in VO2 max, which they tell us is very hard to move without a lot of training to get this improvement. And yet photobiomodulation does this after a single shot. I saw mention of stem cells. I thought it showed that when you put light into bone marrow, these are the baseline figures of healthy volunteers. This is 24 hours later, a mean score of 378% increase in the number of circulating stem cells 24 hours later. And in a randomized trial on acute myocardial infarction, patients treated within hours of their first heart attack here, and then they get multiple treatments over the first few days, and then they're doing blood tests. And what you see here is a reduction in creatine kinase, non-significant, reached 0.08 as a p-value, but troponin T was significantly reduced in this study just by putting photobiomodulation into the bone marrow, treating the tibia. And that's all, folks. Whoa.
Well, James, again, very impressive data. And also underrecognized in the
Yes.
geoscience community, what PBM has the potential for. So it's very exciting. And we thank you for your wonderful presentation, including Star Trek, one of my
Yes.
favorites.
So, yeah, bit more
So
speed, but there we go.
we'll come back to you in a moment, but let's go on to Dr. Chris Rentz, who is and was on Switzerland, a beautiful part of the world, and is founder and CEO of Amazentis. Chris himself is a highfalutin scientist, and we'll have a lot to talk about from a scientific standpoint. So, Chris, thank you for joining us later in the day.
Thank you very much.
Go right ahead.
Okay. Let's see. Is that... Okay. Great. Thank you, Zan, for having me. Yes. So today I'm going to be speaking about nutritional interventions and how we can impact our health span. And, we've been working here at Timeline now for, gosh, it's been over 15 years doing the research that I'll be showing today in just a few minutes. So really exciting stuff. When we start talking about health span, I love sharing this slide here because it shows basically what's happening with our muscles as we get older. And our muscles are peaking their function as we get into our 30s, and then declining. And then, some of us, remain very active until we get old, but then others, start to have problems and muscle degeneration. And this is a good arc of our that shows what our health span is all about. What we want to do is maintain our health at its peak, which I would qualify as the green line here in this figure. And the nice thing with muscle function is it's a great proxy for overall health as we get older. So we're really focused here at Timeline on the impact of mitochondria in terms of improving overall functionality of our body. And if we think about mitochondria as one of the key elements of aging, basically what happens, the mitochondria, as you were hearing in the previous presentation, is all about being the energy source of our cell. It's basically the power plant or battery inside of all of our cell, keeping our cells functioning healthy. And as we get older, what happens is that the mitochondria stops functioning as we'd like it to function. And consequently, what happens is that our cells stop functioning in an optimal way. And this gradually becomes apparent to us as the organs stop functioning as they should, and they're not functioning at an optimal way. And then we start feeling our age, and we feel the decline in muscle function. And there's all kinds of other age-related declines in biological function that are linked to a decline in mitochondrial function. So today I'm going to be speaking about a nutrient called urolithin A that we've been working on now for about 15 plus years. What is urolithin A? It's a naturally occurring postbiotic that's produced by the gut microbiome. So inside of pomegranates and walnuts and different types of nuts and berries, you have this class of compounds that are called elagitannins. And when a person consumes one of these foods, the elagitannins are transformed by the gut microbiota into a compound called urolithin A. And this transformation is something that is not a universally transformation in everybody, because only about a third of the population has the right gut microflora to make this transformation. And it can be either a high level of transformation or a low level of transformation, or somewhere in between, or not at all. And so, which makes it very unlikely in general for somebody just consuming a pomegranate or pomegranate juice to actually get exposure to adequate levels of the compound or nutrient urolithin A. And what we discovered was that urolithin A is more than just a byproduct of the pomegranate and other foods, but it actually acts at the level of the cell, and it stimulates and improves mitochondrial health. And it does this by stimulating a recycling of the damaged mitochondria. And this recycling is called mitophagy. And so this is a little cartoon that shows you sort of a mitochondrial life cycle. And as your mitochondria are functioning and your cell is and they're producing energy, they do get damaged by reactive oxygen species. And what happens is the cell naturally pulls these damaged mitochondria into a pathway that's called mitophagy, which is this recycling process whereby the mitochondria are engulfed, they're digested, and then healthy mitochondria are then than replacing the damaged ones. And this is how our body and all of the cells in our body, with the exception of our red blood cells, basically maintains a healthy cell and with optimal bioenergetics. So we've tested urolithin A for its effects on mitochondria function, and I'll be showing you a few of these slides here. But I think one of the interesting things when we talk about Healthspan is thinking about these model organisms called C. elegans. And they're little worms, and they're a great tool to assess the effect on Healthspan and particularly on lifespan. And so we see here when we feed worms urolithin A, it improves their lifespan by about 45%. And the only intervention that is not a genetic intervention that improves the lifespan of these worms greater is through caloric restriction. Caloric restriction is also another means of stimulating this whole autophagy, mitophagy pathway inside of an organism. So one of our first publications was in Nature Medicine now a while ago, and in this publication we detail how urolithin A is able to impact the mitochondrial function and cell function. And we see that on the left here on the slide, you can see ellagic acid, which is one of the precursors during the digestive process of the ellagitannins prior to being converted by the gut microflora into urolithin A. And so we can see how that sort of really unlocks this the ability to stimulate and enhance lifespan. But I think what's more interesting is when we go into rodents and we take a look at the effect on actual muscle function. And what we can see here is when we're administering for a long term to rodents, we can see an improvement in both the muscle strength and running distance and endurance in the rodents. And that was something that really struck us as very interesting and encouraged us to develop urolithin A further into for human use. And so in this slide, there's a lot of information on it, but I'll walk you through it. It's essentially 3 separate double-blind, placebo-controlled, randomized studies in which we evaluate urolithin A in healthy adults. And on the left, we have our very first study that was published in Nature Metabolism. And in this study here, we administered either placebo, and then we also administered an increasing doses of urolithin A, 500 milligrams and 1 gram. And then we followed people over a 28-day period, and we looked at the impact on cells and the tissue of the muscle in the legs before and after this 28-day period. What we see, and what you can see here on these columns, is each column is an individual, and each line is a different mitochondria-related gene. What we can see is that as we increase the dose, there is an upregulation of mitochondria-related genes in the muscle tissue of these individuals after only a 4-week period of time, which was very exciting and caused us to advance and initiate the second and third trial here and other trials that I won't be presenting here today. But and in the second trial, we administered for a period of 4 months, and what we saw was that we were able to improve leg muscle strength by over 10% during a period of 4 months just by administering 500 milligrams of urolithin A, which is what we call MitoPure. And that was very exciting. And then we took a larger, and that population was a population of 40 to 65 overweight sedentary individuals. And then in trial 3, this is basically an average age of around 70-ish. And what we did is we followed these people, and what you see here is after a period of 2 months, dose of 1 gram of MitoPure improved the muscle endurance in these individuals. And we showed an improvement in muscle endurance in the hand muscle and the first interosseous, as well as in the leg muscle. And so we've been, over the years, we've been doing a lot of science here, and so we're a very science-focused nutrition company, which really distinguishes us from many other companies acting in this in the whole nutrition and dietary supplement space. And we've published a number of articles, whether it's Nature Medicine, Translational Medicine, and Metabolism, all the way to some more recent publications that we expect to come out very, very soon. So it's we've been able, and what's even more exciting is that these publications have inspired other scientists to explore and understand further benefits of urolithin A in different models of cellular health and physiological parameters. So, all of this work, I mean, is destined to go into actual commercial products. And so it's not only looking at mice and humans, but it's also developing products. And so we've gone through a very robust process to take our ingredient, which we call MitoPure, and bring it through the FDA approval process to show that it's very safe. And then develop it into products. And so we've developed into different types of nutritional products. We have gummies, we have soft gels, we have powders, and we've been focusing here on more nutritional aspects in this short presentation, but also another organ, which is our largest organ of our body, which we hold dear to our heart, is our skin. And the skin is bombarded by all kinds of insults daily, UV light, and other types of insults that we might encounter, like pollution. And this also has an impact on the overall functioning of the skin and the aging of the skin. And so we've also developed products that are for topical application as well, and with the aim of creating a holistic approach to health span and longevity that includes both oral nutrition products and topical products. And on my last slide here, I just show you some pictures of our nutritional products on the left, as well as the new line of skincare products that we've recently introduced in a new and been rebranded just this last month. So thank you very much for your attention.
Well, Chris, thank you. You truly are a unicorn in the dietary supplement space. You are developing clinical data on a regular basis and publishing them. And that really is unusual. And the data are quite impressive. It's just really remarkable. And so we will want to come back to you to talk about your long-term goals for developing your platform. Again, thank you so much.
Of course, delighted.
Good. Well, questions to follow. But let's now go to Dr. Roger Shih, who is a professor of pharmacology at the University of Texas at San Antonio. Roger has a remarkable history in therapeutic development. He was at Lilly before going down to San Antonio, and involved with some very important products there. And he has what I believe is maybe the most promising approach that is not yet in the clinic, but I think soon will be. And so as a means of representing up and coming products, we wanted to bring Roger on to show again another way of the mitochondria. And so Roger, delighted to have you, and we give you the floor.
All right. Can you see my screen? Share
Do.
screen? Yeah, all right. First of all, it is really my honor to present our work. I want to thank Zen for the opportunity. It's a rare moment. The previous speaker already highlighted the importance of mitochondria, so I don't give you any more further information. So let me see how to advance slide. Yeah. So aging is going to kill all of us. Aging itself does not, but aging-related diseases are going to kill us. Aging-related diseases selectively affect tissues that are highly dependent on mitochondrial function, which is our brain, the heart, eyelid beta cell, retina, and part of our ear. So they are basically one disease, which is aging, manifested by different tissue. That's all. So the question is, can we treat all aging-related diseases as one disease? Currently, most of aging-related diseases are not that, the treatment for most of aging-related diseases, other than diabetes, obesity, are not that highly effective. For example, heart failure is no effective treatment other than stent, and stroke, another case, this is no effective treatment. And they kill most of us, actually, more than cancer does. Alzheimer's disease, which is another example. So if you understand aging-related diseases, we must understand aging itself. So Daniel Hammond proposed a long time ago that mitochondria control the aging clock. The clock is controlled, is turned on by free radical. The free radical generated by mitochondria damage mitochondrial protein, DNA, and phospholipid. One of the phospholipid, which has been understudied for decades, is the mitochondrial signature phospholipid. It's called the cardiolipin. Cardiolipin is sensitive to oxidative damage, and oxidized cardiolipin itself is a new form of free radical, which turn on this clock and speed it up when we reach to a threshold like middle age, then set us into the trouble for a whole family of aging-related diseases. So what is cardiolipin? Well, it is initially discovered in the heart, but it's a lipid. It's the most complex lipid. It has 4 fatty acyl chains. It is the godsend of mitochondria. Every aspect of mitochondria requires cardiolipin, from curvature of inner membrane to mitochondrial fission, mitophagy, every part of it. That's why cardiolipin is so important. But the function of cardiolipin is determined by fatty acyl composition. Okay, so if you change the structure, which aging does, you're going to change the entire behavior of mitochondria. So here's a good example. The 2 types of clam, one live 50 years, another live 500 years. Then the research found out that the major difference between these 2 types of clam is the mitochondria cardiolipin structure. The short-living clam has high content of polyunsaturated fatty acid in cardiolipin fatty acyl chains. It's called the DHA. The long-lived one, 500 years, have very little or very low level of DHA. So here's the structure of a typical cardiolipin. The healthy cardiolipin has the linoleic acid as the backbone. And the DHA cardiolipin has has 6 double bonds. And this makes cardiolipin highly sensitive to oxidative damage. So interestingly enough, the DHA content is inversely correlated with longevity. This is published a long time ago. People don't know why. So we pioneered, we co-founded the field of cardiolipin synthesis and remodeling. Those are the enzymes we cloned: cardiolipin synthesis, synthetic enzyme, cardiolipin remodeling enzymes. The enzyme we've been working on for 20 years since I left Eli Lilly is this enzyme. So this enzyme involving cardiolipin remodeling. So cardiolipin gets bombarded with the free radical, and this bombardment accelerated by obesity and aging. And the oxidized cardiolipin must be repaired. Otherwise, the cell will go to apoptosis. The repair process takes 2 different pathways. One repair is physiological repair. basically take away the oxidized cardiolipin and reisolate it with linoleic acid, which recover the healthy structure. The enzyme we cloned actually involving pathological repair. It actually enrich the DHA content, which mimics the effect of aging. So we use the animal knockout model. We knock out our enzyme, and we also knock out the telomere guiding RNA, which we know telomere length shortening, which is the golden marker for aging. Remarkably, if we knock out our enzyme at the same time knock out the telomere guiding RNA, the lifespan of a double knockout is doubled. Okay, and this remarkable effect is due to the fact that this is all the measurement from cardiac function to cellular senescence, every part of it being recovered by knockout our enzyme. And we spent almost over 15 years to work on age-related diseases. Initially, we studied obesity, diabetes, fatty liver, diabetic complication, and different model of heart failure. In every cases, if you knock out this enzyme, the mice are protected from those onset of the diseases. The most remarkable one is the mouse model of Alzheimer's disease. If you knock out our enzyme, the plaque number is reduced, the cognitive function is restored. So here's our model. So aging, obesity, generate ROS. ROS induce our enzyme. Our enzyme promote cardiolipin peroxidation, which is oxidation by changing the cardiolipin structure. That set off a whole game of mitochondrial dysfunction and onset of whole family diseases. So this is the holy grail I try to present to you. So naturally, I spent over a decade time at Eli Lilly, lead their early stage drug pipeline. Like I was in charge of the very first generation of GLP-1 analog called exenatide 4. So, I'm a drug hunter. So after the validation of this enzyme as drug target for aging and aging-related diseases, we started building we start doing the typical drug development process. We did heartthrob screening. We raised funds from angel investor. We spent last almost 10 years, improved the inhibitors structure and potency. Now we have 3 clinical candidates to be moving forward. One of it is called the dapagliflozin. So DAPA is very potent. And with IC50, it's about 7 nanomolar. By this stage, the drug company would be very excited to move forward for clinical trial. But as a small biotech company, we run out of cash, and I'm fully involved with university job. So the company basically is at the pre-IND stage. So working for university, we have a platform allow us to test a different mouse model for this compound. One model is aging. So we treat the mice, this is 18-month-old mice, with our inhibitor, which is equivalent to 10 milligram per kg, by supplementing it in the food. After 3 months treatment, remarkable things happen. You can see the treated group, they look very different. The fur color is dense and blackened. And more importantly, they live longer. They live significantly longer. They have much better glucose tolerance. Those are all fresh data. Even Zhang has not seen it. One of the golden marker, which is what called a closal level go higher after treatment. And their cardiac output is like young mice, significantly improved. Their grip strength, their forelimb and forelimb running time, all significantly improved. Remarkable. So here's the treated mice. One effect that when we get older, we are afraid of a cold because our thermogenic activity go down. And this is what happens when we get old. Our mitochondria die in the, this is the brown fat. A lot of mitochondria, nearly all the mitochondria are dead, actually. This is after treatment, completely restored. Another remarkable effect is the cellular senescence biomarkers. After treatment, This is actually a much older mice, 24 months, near the death. After 3 months treatment, all the biomarkers in different tissue of cellular senescence is attenuated. Now, the holy grail question is, can we target aging for the treatment of age-related diseases as one disease? So the first model we tested is the coronary artery disease with permanent ligation of left descending coronary artery. Same day, we gave them compound or a vehicle. So this is what happens with the vehicle treatment. By the way, a third of mice die within 48 hours because it's like heart failure, heart attack. So DARPA treated not only zero deaths, but prevented dilated cardiomyopathy and heart failure. This is the morphology. This is the volume. This is left ventricle function. Remarkable. Think about it. People consider that heart failure is a vascular disease. Here, you permanently ligated left descending artery and minimize the damage to mitochondria because our enzyme promote mitochondrial damage in response to hypoxia. So another model is the hypertension model. This aortic constriction after 2 months, they develop the same thing, dilated cardiomyopathy. The treatment also restored. This is measurement cardiac function. The most horrible disease is Alzheimer's disease. We analyzed the expression level of this enzyme. So later stage of Alzheimer's disease patient, this expression level of this enzyme goes sky high. In rodents, this is APPPS mice. This rodent the brain has very little ALCAT, but in the AD mice, the expression level goes sky high. So what happens if you treat the mice with this compound? So this is after 2 months, or I think it's a 3 months treatment. This is the water maze test. You can see the AD mice have the trouble to have a memory. This is the compound treat. This is compound. This is a control mice. This is control mice. This is our compound treated mice. This is quantification. So the water maze test showing that this compound restored memory. This open field test is same thing. It restored the activity. Most remarkable, you can see tau phosphorylation after treatment completely attenuated. I never see any compound could do so remarkable change. The tau phosphorylation got the mice develop tauopathy. It's called tau tangle. So those data actually speak very loud that age-related diseases is one disease manifested in different tissue, and cardiac remodeling by this enzyme is root cause for aging and linked aging to age-related diseases. Oh, this is cellular senescence. This obese mice has huge accumulation of synaptic cell in the abdominal. This is after 2 months of treatment. So in summary, using dapagliflozin, I mean, each disease I could spend an hour to present the mechanism, including mitochondrial fusion, fission, mitophagy, senescence, you name it. But I will summarize dapagliflozin treating whole family of aging-related disease as one disease, which I'm hoping to accelerate to move to human clinical trial. It will save a lot of life. With that, I'm closing with this graph. So Zen Fleming saved all of us. This is Alexander Fleming. He's my hero. Because without penicillin, we probably, most of us, are not here. So within a few years, it doubled our lifespan. But now aging is getting us into trouble because aging is a new disease. Aging is a completely new disease. We are not entitled to have aging 100 years ago before Alexander Fleming. So I'm hoping DARPA would liberate us and at least live a healthier life. And aging is not a new story. 2,000 years ago, the Chinese emperor begin to do research on aging, try to find longevity medicine, and try to send his missionary to Japan, to East China Sea, but they never return. Hopefully, DARPA would fulfill this role. With that, I want to thank you for the opportunity to present our work.
Well, Roger, thank you very much. The data are just amazing, like all the other data we've heard.
Yeah,
And
this
the promise is spectacular. I think we all want to see you go as fast as you can. And by the way, thank you for mentioning Uncle Alex. Glad to be associated with that name. But let's now go to questions. And we've got many, many good questions that could be asked. I'm going to ask Michael Zimmel to start off, and he can maybe direct a question back to Roger.
Sure. Roger, you've got really terrific data, very impressive data in disease models. Would the next step, or I wouldn't ask it as the next step, have you done any work on prevention of disease in normal animals or in animals that are in a pre-disease state? Or is that contemplated?
Yeah, I'm a drug hunter. Prevention would be something for nutritionists. We do have a whole body knockout mice, which is like preventive, because the gene was knocked out from embryonic day one. And those mice live longer. They are completely protected from every age-related diseases. So I think for prevention, it surely work. Actually, one of my colleagues proposed, say, hey, Roger, this will be a huge market for nutraceutical if you could, get the FDA approval. I said, no, most people will not take medicine until they're sick. So, but it's a good direction. If I think billionaires should pay for it because they always want to live longer. This probably will most likely compare with all others like AAV plus, metformin, rapamycin, you name it. But this one sticks in every direction we look. That's how remarkable. I was shocked by the phenotype of the mice after treatment. Yeah.
Well,
Thank you.
thank you, Roger, and we'll come back in a moment. But why don't we go over to Josh Hare? Glad you're back from NIH, and just again to say you've got data, you're in late stage, you've got an agreement for a seamless phase 2, phase 3 adaptive trial with made agreement with FDA, and so you're well underway for these for targeting immediate hallmarks of aging. But can you imagine Lomecel being used in a relatively healthy population? What would be the feasibility of that? And I might mention that I noticed in your frailty study that you're using TNF alpha to select presumably higher risk patients with frailty. And so perhaps you could talk about strategies for targeting products to people who would be likely to respond.
Thanks, Dan. Those are collectively great questions. A lot of points to address there. Basically, the use of these types of products as a pharmaceutical or a preventative therapy, there's a tremendous enthusiasm for this, especially amongst patients themselves. This is something that has been sought out for a long time. There's the strong perception, I think, validated by evidence, that one of the key points to make about mesenchymal stem cell infusions is the safety profile. It's incredibly safe. If you compare mesenchymal stem cell infusions to standard pharmaceuticals, the safety profile is better. And I think this makes sense that these are derivatives of the human body itself. And in a way, we're taking a cell population out of the human body, amplifying it and giving it back. Of course, it has to be made with the proper quality control by properly trained individuals. The risk would be that if untrained individuals or improper facilities are used, that there could be a risk of transmission of infection. So long as those never. So long as that is attended to, then there is no risk. And a large there are large safety data sets that prove that. So this has led to a demand for these products. The problem is the supply, that they are expensive to manufacture and the amounts require large scale production. Now, having said that, there are lots of individuals seeking these treatments, and there are lots of states are adjusting state laws to allow for the use without FDA approval. Florida has passed a law as that. So I think we got two societal issues here. One is I think that the FDA needs to start approving these as drugs to those individual organizations that are applying, such as Longeveron. And we work very closely with FDA. We have RMAT designation around the Alzheimer's. We're hoping to get through that phase 2, phase 3 trial. It will be very expensive, though, and the expense of that trial will necessarily delay the conduct of that trial and the approval. So if that could be hastened somehow, if FDA regulations are changed for this particular indication or this particular product, we'd love to see it get to market as soon as possible. Now, the flip side of that is, okay, let's say we get approval to treat a disease. Should people be taking it as prevention? And again, I think the safety plays a key role there. There are some people seeking these types of products and are taking them for prevention. It appears to be safe. It's harder to gather the clinical data in that kind of scenario relative to a well-conducted phase 3 clinical trial. On the other hand, I think what you will see is more and more usage in the state of Florida. It's now going to be legal for athletes who have any kind of athletic problem to seek treatments. And I think you'll see that they'll be used more and more for prevention. I was very intrigued by James's data also on his intervention for athletics and potential prevention of damage in high performance athletes. So this is an exciting, fast moving field, and it's going to be changing year by year.
Well, thank you very much, Josh. We'll hope to come back. And Chris, you do have another product that got plenty of data that improves mental health. Michael, over to you to ask Chris.
Sure. So first of all, Chris, kudos for bringing outstanding scientific rigor to the supplement space. It's something that is sorely needed and rarely done. So kudos for that. What is the role of evidence-based supplements overall in extending healthspan? Urolithin A, but supplements writ large, evidence-based supplements in extending healthspan.
Well, I think we're really at the early stages on taking, as you said, advanced science and really exploring the use of supplements and validating them in the clinic. With urolithin A, of course, we focused on really trying to show in humans the various benefits at the cellular level and the tissue, showing that we're actually able to stimulate, improve mitochondrial function, stimulate mitophagy, and actually stimulate an improved functionality of the tissues, whether it's muscle function, muscle endurance. Recently, we've been looking also at immune health. And so we have a paper that should be coming out soon on immune health, where we We looked at people, average age around mid-50s of individuals who were healthy, taking our product, 1 gram of MitoPure during a month period, and we were able to show a change in the immune health of these participants. And I thought that was very exciting. We showed basically an improvement in mitochondrial function in the immune cells. We took cells before and cells after, and we did a very deep phenotyping together with the Buck Institute and Eric Verdun over there. And this was done with Professor Dr. Florian Gretten over in Germany, who was the principal investigator for this study. And what they showed was that over a month-long period, they were able to increase the number of CD8 T naive cells in the overall population, which was really quite phenomenal. And they were able to see an improvement in mitochondria function, and that was able to be measured just by drawing a blood draw. And so this is something that is very exciting to see that, you know, we can take nutritional interventions and then validate them clinically and show that they can have an important effect on various attributes of our health that are very important to our health span, whether it's, you know, muscle function, which I spoke about as being very important and the bedrock really of our health, and then as well as immune function. I see this continuing, and I see nutritional interventions as being a very important element, but not a replacement for good diet, exercise, you know, and lots of, we all talk about now the importance of sleep, that you know, having a holistic approach is key for health span. But if you can take the right supplements that are acting on key pathways of aging, like in our case, mitochondrial dysfunction, I think that's really exciting. And you know, and we've been very fortunate to have identified urolithin A as a very important nutrient that acts on mitochondrial health, and we're also very pleased to be able to offer that to people through our Timeline brand, that you can go online and just order that and have that come to your home. So it makes it very easy for people to have that nutritional intervention, and you know, breaking down those barriers is very important.
Very exciting, really. Back to you, Zan.
Well, and thank you, Chris. It's remarkable what you can now do with a product that is on the market and available to people. And we really are excited about what you're doing and committed to doing. And thanks again for emphasizing the foundational approaches to targeting healthy longevity. It's lifestyle, safe and effective. It needs to be done first and foremost, and then all these other modalities can help. And by the way, it's conceivable that the 4 products that we've been talking about could be used together, or at least in some combination. So anything that works, and presumably if it works, it will tend to work or help another product with a different mechanism to be even better. And so that's yet another prospect. But let's go back to James Carroll. And James, likewise, you have so many compelling data in treating disease conditions. But for a medical device, doing a prevention trial is a daunting proposition. So what is your thinking about pursuing a so-called Healthspan claim that would be showing that you can actually prevent 2 or more chronic conditions, or at least improve them in some way?
Given that, as has already been said, I mean, if you maintain a healthy lifestyle, so that obviously involves, as I said in our pre-meeting yesterday, the first rule of longevity is to not die. Then the leading cause of death is cardiovascular disease related, atherosclerosis, and obviously diabetes and cancer and Alzheimer's sort of following up. And we know that exercise is a major component of that. So we contribute to people's ability to do exercise, and so their outcomes are better if they're using light as part of their exercise regime. As I also showed, when we treat the side effects of chemotherapy and radiation, that is a pre-treatment before they have any symptoms. We are doing something to cells sufficient that they become resilient to the effects of radiation and chemotherapy, the adverse effects of it. And there's no sign that these things are reducing the efficacy of chemotherapy and radiation. If anything, there's some hints of a trend that maybe the cancer treatments are better. So we're doing something to healthy people that makes tissues more resilient. Now, I can't explain what, we don't know exactly what that is. We think there's NF-kappa B and AP1 are both involved as transcription factors. But we don't know more than that. There are fruit fly studies that show longevity. You can give these flies light every single day, and they seem to have a much better sort of health and lifespan. They die off more slowly than a control group that doesn't receive any of it. There's studies on the brain of mice where they apply photobiomodulation to 5-month-old mice, for 7-month-old mice for 5 consecutive months, every single day for the treatment, and there's a reduction in the microglia and astrocytes in the brain of aged mice compared with untreated mice, and they compare well with 3-month-old mice that didn't receive any treatment. So I think absolutely this is an area to be considered. Obviously, it's hard to do 100-year-long studies in humans, but in short-living creatures, this seems to be working. Did I answer the question?
Well, I think mostly. I guess there's a practical question here, and that is, could a medical device company, with all the considerations involved, without having sort of a corner on the market, so to speak, afford to do a prevention trial that could cost many millions of dollars?
Yeah, that is a difficulty, isn't it? I suppose the true answer is, for as long as how long do these have to be to prove longevity? I suppose you'd have to prove if there were reliable biomarkers that FDA would recognize.
We're working on that.
Markers of health, if we can show those, and if that means that it takes 3 or 5 years, then I think that's something industry could consider. But if it's going to be 10, 20 years, it's not that industry can't have a registry and start looking at early biomarkers and keep following patients for decades. But if you can get it on the market with earlier with some kind of health and longevity claim, Healthspan claim, and obviously that would be nice.
Well, thank you. That actually is exactly what the Thrive Act intends to facilitate. So again, I urge everybody to take a look at the details of the Thrive Act that's available on the Catalyst website. And I wish that we had much more time for questions, but we've only got about 7 minutes. So I wonder if you can provide some other questions, Michael, that the audience has been putting to the panelists.
Absolutely.
And let me just cue up Thomas in case he's fallen asleep in Hong Kong. We'll put him on to ask a question or make a point in just a moment.
Excellent.
He's awake.
There he is. So, Thomas, before I jump into questions.
Yes. What was the question? I've been fascinated by this discussion, and struck by the fact that this would be of enormous interest to the people who are attending this conference. This is actually, Suzanne, not a geroscience conference, but the APAC, Asian Pacific Longevity Medicine International Summit in Hong Kong. And I've been just surprised. I don't know if shocked is the right word, but it was unexpected to see this huge rise, rapid rise over the last 5 years in the phenomenon of longevity medicine clinics. We've been, looking at product development, and on the back end, there's this enormous exploding interest in applying things that science is demonstrating on behalf of patients. So obviously, we want to be sure that regulatory requirements are met, but with marketed products such as urolithin A supplement and with photobiomodulation, I think that these kinds of data are going to be of great interest to. Actually, we have a huge a delegation from China. So we have 50 or 60 longevity clinic sort of groups that are wanting to push these kinds of solutions through to thousands of patients. So we're going to see a lot of data, I think, if they can be captured instead of just part of medical treatment.
Thank you,
And
Thomas.
Josh's cellular approach will also be of great interest to these clinics.
Oh,
And he
absolutely.
mentioned that as
Yeah,
a thing.
this has become a major trend around various geographic locations, particularly in Asia and Latin America. There are quite a large numbers of U.S. Residents leaving the U.S. to seek these therapies, and this is a growing trend, and it'll be of great interest to see how this plays out over the next few years.
Well, that is both maybe an opportunity and a challenge. We want these to be evidence-based, and as you know, that's not always the case.
Right.
So that is one other feature of the Thrive Act, to encourage kind of investment in acquiring data that all of you are part of. And we therefore applaud all of your efforts in that regard. Michael?
Yeah, so I have a question for James from John Ferber, and I'm going to expand on it a little bit. He asks about light, color, range, and frequency. And just to expand on that, James, is it a single wavelength or wavelength range for all the different applications? And are there applications for which that require specifically laser, perhaps for depth of penetration, and others that would require LED or would do with LED? Can you comment on the uniformity, I guess, of treatment across applications?
So that's wavelength and lasers, a main topic. So in the question there, so it seems that you can look at the absorption spectra of any molecule, and that includes cytochrome shock stays in mitochondria, which seems to be the main target for photobiomodulation. I'm not saying there aren't others. There are certainly some membrane changes which occur with infrared light. But sticking to the one where we have the most evidence is in mitochondria, and specifically its effect on cytochrome shock oxidase, and we see the oxygen consumption and the ATP changes and the better behavior of the electron transport chain, fewer reactive oxygen species. The why is when looking at the absorption and the absorption spectra of cytochrome shock oxidase, it looks like there's some very specific targets, and the best ones are in wavelengths which you start moving through to the green area and blue areas of the spectrum. Look like those should be the wavelengths for PBM. The problem is the light doesn't penetrate the tissue very well. The reason we can all see each other today is because visible radiation is bouncing off of our faces into the camera, and that's why those wavelengths are unlikely to have any useful clinical utility. And yet they seem to be optimal for absorption in cytochrome shock states. There is some absorption in the red and in the near-infrared spectrum. So in the middle of the red range and the middle of the 800 range, at least those are the ones that have been published. There may be others. And it seems that even though they're relatively small in terms of absorption and action spectra we see in those wavelengths, they seem to work. How sharp are those peaks? How accurate do you need to be? It's very clear that in the 800 spectrum, it's quite broad. It's narrower in the red spectrum, so we're talking about several tens of nanometers spectrum via the peak, which is around 835 nanometers, but through to 850, 860, and much shorter down to 800 nanometers. People are getting effects. I've seen many wavelengths used way outside where the peaks are for it, and they too seem to work. And the thing that most people, even in industry, people who make these things don't realize, certainly when you're using lasers are never the wavelength they say they are, because even if when you turn them on, by the way, when you purchase one, they can be plus or minus 5 or 10 nanometers. You can spend extra money, get them closer within 5 nanometers. As you switch them on, let's say you do have one of your preferred wavelength, it moves as it warms up. So the wavelength changes. So if you haven't specified a wavelength, it's not the one you probably see published, because nobody tests these things, and it moves anyway. And yet all these positive studies seem to occur. So I'm uncertain about really how accurate the importance of wavelength. It is somewhat important, but there's precision. Oh dear, this one's 2 nanometers different from that study there. I think that's unimportant. If you're talking range of 10 nanometers, then it becomes more important. So tens of nanometers then becomes important in terms of, and you want one that penetrates. Red is better than any other part of the visible spectrum. Near infrared is better, and I'm talking about in the sort of I don't know, just about in the 8 to 900 range is the best sort of penetration. There is another part in the spectrum we get beyond 1050 nanometers, and there's another good penetrating spectrum that needs more investigation to compare efficacy with the other near infrared ones. Sorry, that's long and it's nerdy and it's outside people's most competence, and they've used a lot of words that are new to people. The subject of lasers is just to get that one out of the way. There's in terms of light penetration, it's the wavelength that counts, not whether it was coherent or not. Laser light is coherent, LED and LED light is not coherent. There are people who argue that because when you have coherent light, you can see speckles in the visible spectrum. You can see speckles, and it's an interference pattern. It's a trick of the light on the back of the eye. And the idea is that somehow, as these waves maybe photons are reaching the same molecule simultaneously and having double the effect. Actually, one molecule can only absorb, or one atom can only absorb one photon at one time. So this seems unlikely to be true. Nobody has done an adequate study comparing laser with LED to absolutely compare light for light, all other parameters the same, the wavelength, the intensity, that means the beam area, everything identical, only difference was coherence. Nobody's done that study. Anybody goes around claiming lasers are better than LEDs or the other way around it's not true. A perfect study has not been done. So, and the studies that prove LEDs are better, the studies that prove that lasers are better.
Well, James, thank you for those details.
Killing you with the details.
Yeah, well, it's fascinating. And gosh, we have run out of time. We have done over 90 minutes, and we always let the formal audience go, or the formal part of the program go. But those folks that are willing, both panelists and the audience who want to stay on, will keep going. But before we completely end, we'll turn it back to Michael for just some final comments. But first, I want to thank the panelists for an amazing discussion and presentations. It's just incredible what all of you are doing, and it's so important. We want to keep encouraging you to keep going. Michael?
Thank you.
Absolutely. And I also want to thank you. I'm sorry we've run out of time because in addition to the questions that were in the chat that we haven't gotten to, I've got a list of my own. This has been a fascinating set of presentations. But in order to finish up the formal part, and we'll stay on afterwards, just a little bit of additional housekeeping. Just a reminder, everyone will receive, all registrants anyway, will receive a link to this recording within the next day or two, along with additional announcements of future Targeting Healthy Longevity sessions, including the October 15th fireside chat between Bill Hazeltine and Larry Steinman on pursuing healthy longevity. That is going to be one for the ages and should not be missed. With that, the formal portion of this event will close with many thanks to the panelists and to you, the audience, for your attendance. We will be leaving this webinar open for a period of time for those speakers and audience members who are able to stay, chat, ask some more informal questions. Thank you.
Thank you, Michael, and thank you all in our audience. And for those who can stay on, let's keep going.